Hello, ladies and gentlemen. All right, so today we're getting back to more polynomials and especially more factoring. All right, so just to kind of review where we've been in the land of factoring, let's look at some of this information. So, we've been factoring things that mainly have had an x squared in them, ax squared plus bx plus c, that sort of thing. But today we're going to factor by grouping. And we do that when the degree is higher than a quadratic. Okay, so it's bigger than 2. So it's going to be at least 3. And usually that requires a couple of steps, okay? And so with that focus in mind, here's what we need to know. We need to know that we're going to need to separate the equation into 2 groups. And I'd like to hope that since there's 4 terms, that means you're going to divvy it up into 2 and 2, all right, in parentheses, okay? But those aren't going to be our factors, okay? So those are not the factors yet, okay? Because what you're going to do is you're going to look for a GCF in each of those pairs. That's a greatest common factor. And then you're going to make sure that after you take the GCF out, the factor left over in the parentheses is the same. Okay, that's really key. So that's the one in the parentheses, and I'll show you what I'm talking about in a moment. And then you need to reorganize so that the GCFs you took out are in another factor, in one other factor. So here's what I mean. So step 1, separate, there's 1, 2, 3, 4, separate into 2 groups of 2, okay? And then we're looking for a GCF. So in the first 2 terms, I see that there's a number in front, but 3 and 8, 3 is odd, 8's even. They're not both divisible by the same thing. So I don't think I can divide by a number, but they both have x. In fact, they both have x squared, so I can divide that out. Which means that 3x minus 8 is going to be left over, because if I divide this by x squared, then the exponent, the degree, has to go down to 1. And if I divide this term by x squared, then it goes away altogether, okay? So then I have to look at my second 2 terms. Now, a rule that I know is that if the last number is a 5 or a 0, you're divisible by 5. So I'm going to try dividing by 5 and see what happens, okay? So that means I divided by positive 5, and 15 divided by 5 is 3, so 3x. Negative 40 divided by 5 is negative 8. Now, this part where I was talking about being the same, oh, I thought that was my highlighter. Whoops. This is what I meant. Do you see how that factor that I just highlighted in yellow is identical? That means this worked for grouping, you did it right, and now you're almost done with your factoring. So the factor that's in parentheses, that we definitely know is one of the factors, 3x minus 1, or sorry, minus 8. 3x minus 8 is a factor. And then I was thinking about 1 as in like this one versus that one. The other factor, x squared and 5 were GCFs, were greatest common factors. So we can put them together in our second factor. And then this is the answer. This is the fully factored degree 3 polynomial, okay? So I'm going to do a couple more for you, and then some others I may just write the answer down so you can check to see how you did, okay? So number 2, same idea. I'm going to break this into 2 groups. I'm going to look for a GCF. It looks like they both have an x squared. So I'm going to get x plus 1 in parentheses. And then over here they are both starting with a 2, so that's definitely going to be divisible by 2. So 2x divided by 2 is x. 2 divided by 2 is 1. By the way, if it helps, you can write what you think you're dividing by underneath your terms to help you visualize what goes in the parentheses. There's nothing wrong with that. So let's see, f of x should be x plus 1. Yep, I got the exact same factor in both of those. And then multiplied by x squared plus 2. So that would be our answer. All right, we're doing good so far. Okay, next 2. All right, so in this third one, same idea. I'm going to group these terms into 2 groups. And it looks like in the first 2 over here, 2 and 5 aren't divisible by anything. So far nothing, no number has been taken out of that first one. But again, x squared is definitely part of both of those. So 2x plus 5. Now in these second 2 terms, so we've got an even number and an odd number, but so it can't be an even number, but I can divide them both by 3, I think, right? 6 and 15 are both divisible by 3. But one thing I want to point out to you, if this is leading your set of 2, is negative, you want to divide by the negative. Like you want to divide by -3, not just 3. So anytime there's a leading negative, you want to take that out along with whatever number you find. So that's going to change -6 to +2, right? Because 6 divided by 3 is 2, and a negative divided by a negative gets me a positive 2x. And then a -15 divided by a -3 is going to get me a positive 5. And if you notice, by doing that, by taking out that negative, we've made sure that our factors are going to be the same. So f of x equals x squared minus 3 into x plus 5. Okay, now I want you to pause this video, pause, and come back and check out a couple of these answers, okay? And see how you did, all right? See you back here in a few. Make sure you take some time to try these on your own. All right, here's your answer to number 4. I would check your factors and your final answer to see if it matches with mine. You should have gotten 4m squared minus 3 and 5m minus 2. Now, stay tuned if you want to hear the next answer, or pause if you want to wait and try it on your own. Folks, if you want to check your next 2 answers for problems number 5 and 6, here they are. One thing I do want to point out is, if you don't remember this from our earlier days of factoring, the order that you write the factors in doesn't really matter. So you could write 3w plus 5 first, and then 4w squared minus 3. All that matters is that the individual factors are correct and that you're multiplying by them. So in purple, here should have been your answer for number 5. And then in blue, number 6's answer was 2x plus 7 and times 5x squared minus 8. Now, again, I would pause if you haven't done 7 and 8 yet and you want to check those answers, or I would just stay tuned and the answers will pop up in a minute or in a moment. Hey kids, folks, you are kids. I mean, not like little kids. Anyway, that's a whole separate thing about that. Anyway, not important. What is important is, did you get these answers? I really hope you did. So for number 7, you should have gotten m squared minus 2 times 5m minus 4. That's over here. And then 3w squared minus 4 times 2w plus 5. All right? Okay, and now for these last 2, I actually do want you to kind of stick with me on this because I'm going to explain these in a little more detail because the directions are different. Whenever it says solve, it means you need to set your factors equal to 0, okay? This is something we sometimes forget about, okay? So what we've been doing for the last like 8 problems is the first part. You've been factoring, okay? So the first 2 steps should feel the same. Group the terms. By the way, I'm pretty sure this first term right here should be an m, okay? That's just a typo. And actually, now that I'm looking over here, this should be an x. All right, yeah, those should all be the same type of variable. My apologies on that. So we've got m squared and then m plus 3. And then it looks like there's a negative in front, and then I can divide both of those numbers by 7. So it's going to get me -7 on the outside and then m plus 3 on the inside. So my two factors are going to be m squared minus 7 and m plus 3. And at this point, you would be writing g of x over here on the left side and calling it a day. But because it says to solve, okay, I'm going to color code this word in purple. You're going to put a 0 right here, because what you want to do is you want to know when m plus 3 equals 0 and when does m squared minus 7 equal 0. All right? This first, and these are just equations that we already know how to solve. We can get m by itself. M is going to be equal to negative 3. And then over here, we would add 7. So m squared equals 7. And then we did this in our last unit. When we have a squared all by itself, we take the square root. And so m is equal to the square root of 7 and the negative square root of 7. And that should make sense that we get two answers there and then another one there because we are degree 3. And if you remember, the degree tells you how many solutions you should get. So if we have the degree 3, we should get 3 answers, right? Okay, and then this second type of the solving problem over here, which is our last problem for our notes. We're going to separate it again. Oh shoot, I covered up to 7. Whoops. Into two groups. Oh, those are some big numbers. So suppose I try to divide these by 2, let's say. Divide by 2. 32 divided by 2 is 16. 28 divided by 2 is 14. If I look at these two numbers, so by the way, what I'm doing right now is I'm just trying a number to see if it's the greatest common factor, and if it isn't, I'll just go back and I'll use a different one. So I bring this up because if I divide by 2, I get 16 and 14, but 16 and 14 are both divisible by 2. So my guess is I probably have a GCF of 4 because 2 times 2 is 4. So let's try taking a 4 out. 32 divided by 4 is 8. Oh, I haven't even looked at the variables. X cubed, x squared, oh, and x squared for sure. So 8x then. And negative, so 28 divided by 4 is 7. And no x because we took both of them out. And then in that second set of factors, we're leading with a negative. And, oh wait, that's almost the same factor, but not, right? Because the signs are different. Well, it looks like 8x and 7 don't have anything in common. When they don't have anything in common, nothing in common, they have 1 in common because everything is divisible by 1. So we're going to take out a negative 1. So that's going to change the 8x to positive, the 7 to negative, and now we've got the exact same factor. So it looks like we've got 4x squared minus 1 and 8x minus 7. Okay? So I'm going to set each factor equal to 0. 4x squared minus 1. 0 equals 8x minus 7. All right, so it looks like I have to add 1. 1 equals 4x squared, and then I'm going to have to divide by 4. So that's going to get me a 4th equals x squared. Now, you may do this in your calculator, but I just want to let you know, you can take the square root separately. Like the square root of 1 is 1, the square root of 4 is 2, so that's going to be equal to x. But there's also a negative 1/2, right, because we took the square root. So there's 2 of our answers. And then over here, I've got to add 7. So 7 equals 8x. And I've got to divide by 8. So x equals 8 over 7. And again, 1, 2, 3 numbers, and the original equation was to the 3rd power. All right, well, that is the end of our notes. Thank you so much for listening. I hope you have a great rest of your day, and we'll catch you back here real soon. All right, bye.